So we're going to do some multi-step inequalities, the same thing as equations, except now they have the less than, greater than, less than or equal to, or greater than or equal to symbols between them. So follow the same rules. Only thing you have to remember on inequalities is there are a couple extra things to remember, and we'll get to those. So you want to get these w's on the same side of the equation for the first example. I'm going to subtract 5w from both sides. Since they're on opposite sides, you have to do the opposite operations. If they were on the same side, we would just combine like terms. So 3w minus 5w is 2w negative plus 7 greater than or equal to positive 9. The w's canceled out on that side. Next step, since I put the w's to the left, I'm going to subtract 7. The 7's cancel out, and we're left with negative 2w is greater than or equal to positive 2. And it looks like our last step, divide by negative 2. W on the left, negative 1 on the right. Here's one of the big rules. If I multiply or divide by a negative number on both sides, I have to flip the sign around. So instead of w greater than or equal to, it's less than or equal to. The reason I say multiply or divide on both sides by a negative is because sometimes if we had something like this, a real simple one, to solve that one, I would divide by a positive 2 on both sides. That negative 8 on the right side has nothing to do with it. So this one, you would not flip the symbol. It would still be x is less than or equal to negative 4. It's only when you multiply or divide by a negative on both sides. If I have w divided by negative 5 is greater than 3, I'm going to have to multiply both sides by negative 5. So w is less than negative 15. So there's an example where I do have to flip it. Okay, next example, let's do distributive property first. I've got a negative 3 out there. So I get negative 3c minus 12 minus 2 greater than 7. Again, these guys are already on the same side. I'm just going to combine like terms. No opposite operations when they're already on the same side. So negative 12 and negative 2 makes negative 14. Now I can do an opposite. Since I'm doing it to both sides of the inequality, negative 3c, the 14's cancel, and I'm left with positive 21. Last step, again, I'm dividing both sides by a negative. I'm going to flip that symbol around. It's going to become c is less than negative 7. Okay, another example. Number 3. Notice that variable on the right side, so we're going to talk about the graph on this one also when we're finished. So I'm going to start off with distributive property again. What am I distributing? I'm distributing a negative 3. So 16 less than or equal to 4 minus 3n plus 39. Negative 3 times negative 13. I'm going to combine like terms on the right side. So I see a positive 4 and a positive 39, which is 43. And I still have minus 3n. So I'm going to subtract 43, which is 27 negative. I'm going to double check that because I'm not sure that that's right. Oh, I'm right. My gosh, I'm surprised. Right side, I still have a negative 3n. 43 disappears, but that negative is still there. And once again, I've decided to pick 3 examples that were all dividing by a negative at the end, which means flip the symbol. So we get positive 9 on the left because a negative divided by a negative. The sign flips, or the symbol, and is isolated. And here's where I have trouble graphing. That says 9 is greater than or equal to n. That means 9 is bigger than or equal to any of my answers. If I flip this around, it's the same thing as saying that my answer has to be less than or equal to 9. Now both of those are correct. One of them is easier to graph than the other. I guess it depends on the person. If I was going to graph this, there's 0, 9's up here somewhere. This is a closed circle, remember. And I want to shade answers that are less than or equal to 9. All right. There's your review of multi-step equations, except with inequalities in them. Don't forget to flip the symbol only when you multiply or divide by a negative on both sides. Have fun.